Hi, my name is Jonathan Hopp, and I'll be the instructor for this course on TypeScript. All right, TypeScript is a wrapper around JavaScript. If you don't know what that means, we'll get into it later. But basically, the uptick is that JavaScript is the most popular language out there. It's made APIs, servers, pretty much anything is built in JavaScript. But JavaScript does leave a little bit to be desired in the opinion of some devs. So one day Microsoft came up with TypeScript, and TypeScript sort of like covers up JavaScript. It's basically made to deal with what some people see as JavaScript's deficiencies. So once you learn TypeScript, you can make an Angular app, you can make a React app. A lot of companies are, migrating towards TypeScript, so learning it can be very advantageous for you in the job market. All right, let's get started by installing TypeScript. Then I'll talk about what we use it for, and then we'll get right into the coding. Installing TypeScript is a snap. Basically, TypeScript we can install using npm. So if you already have like Node.js and npm installed, you'll be fine. We can do npm install -g TypeScript. Now, a little small note, probably when you go to your job, you will not install TypeScript globally because you may have different versions for different projects, which is fine. We're just going to install it globally just for the sake of this tutorial, so that'll be easier on you. Right? So you can just do npm install -g TypeScript, and it will bring up the little like progress bar. It'll take no time at all. And now you might be wondering, well, how do I actually create a TypeScript project? All right, so we're going to need the compiler, and the compiler needs a configuration file, something that basically says, like, here are all the different things that TypeScript needs in order to compile. You'll see what I mean in a second. The command is tsc, 2 hyphens, init. And it'll spit out this tsconfig.json. Let's take a look at what is inside this thing. This thing is a beast. And I will be completely honest, I don't know anyone who knows all of these different options, right? There's just so many options. But the general thrust is that tsconfig.json is all of the configurations for the compiler, right? So TypeScript has a number of options that you can use and like tweak depending on what you need, right? So for example, you can use a different JavaScript language version. That's what you wanted to do. All right, you could do whatever it has target. So for example, you might need to switch from 2016 to 2020, for example. All right, that is something you might need to do. Okay, there's modules, CommonJS. There are so many things in here. Like I said, most people don't know all of what's in here. Most of the things you really do need to know about are strict. It's true if you want to, for some reason, disable strict mode. There's ES module interrupt. You may have to set this to false under some circumstances. But other than that, mostly you'll leave a lot of these things alone. All right. The only thing you might need to do is like change the out file and outdir, which we'll do later. I'll show you how that works. But yeah, this is all the compiler options. So if you ever need an option, you can just uncomment it like this, and then the compiler will just know, okay, cool, we'll use this option. Other than that, I would not really do too much in this file if you're just a beginner. Just kind of leave it where it is, especially if at your job, someone's probably already configured everything the way they want to, so I would just leave it. But basically, this gives TypeScript the configuration it needs to do its job. We'll see what that means in the next section where I actually discuss like what TypeScript actually is. So what is TypeScript? Most people will say TypeScript is a superset or wrapper around JavaScript, and that's correct. And I'm not arguing with that. But I think an easier way of understanding what TypeScript actually is doing is that you are still coding in JavaScript, except TypeScript is sort of like a nun behind you, watching you as you type to make certain that you're typing things correctly. Like everything's consistent, that your program works the way you think it does. So could you program without TypeScript and write like regular JavaScript? You most certainly can. A lot of companies go to TypeScript because it gives type safety. If you say something's a string, it's a string. If you coded in C# or Java before, you understand exactly what I'm talking about. If not, that's perfectly fine. But let's kind of get into what TypeScript actually does at the end of the day. So I've got an index.ts file. So .ts indicates that it's a TypeScript file. I've got my tsconfig.json, so we've already got everything set up. We're ready to go. And I've written console.log hello world. This is something you would normally write in JavaScript anyway. And so, like I said, we're going to still be coding in JavaScript. So if you don't know JavaScript very well, like I mentioned before, you really should go back and look at my video about the introduction to JavaScript, and that way it'll make more sense to you. Let's actually transpile this. So what I mean by that is I'd like to take this .ts file and turn it into a JS file. So the command is tsc, TypeScript compile, and then we are going to do the name of the file, which is index.ts. Hit enter. Wait a few seconds, and it will spit out an index.js file, which will have the same code. Now, you may be thinking, well, that was nothing special, like console.log hello world. That's because there's nothing really here to transform. Okay, but essentially what we are doing is we are saying, okay, cool, I coded a bunch of code in JavaScript using TypeScript types to help me program, and then it's going to transpile into this .js file, and the .js file is the actual file that will be run. Okay, so when you do like React and Angular, they'll do this step for you. You won't have to do it yourself. But if you ever want to see like what TypeScript is doing, what TypeScript produces, it produces a JavaScript file, and the JavaScript file will be ready to run, and that will be pretty good as far as maintaining type safety. All right. And again, if that isn't the thing you really need, then you can just code in JavaScript. But TypeScript is a great way to have type safety, and it can help us avoid a lot of subtle bugs that would be a lot more annoying to debug in JavaScript. And that's kind of the point of having TypeScript. All right, so we've done that. Let's talk a little bit more about what TypeScript actually does for us. All right, so console.log hello world is, just vanilla JavaScript, nothing to say here. What we can do now is we can start to introduce variables. All right, so we're going to do, like, for example, let first name equals Jonathan. This is a typical line in JavaScript, let variable name equals something. And then JavaScript knows it's a string because I put the variable inside quotes because it's a string. In TypeScript, we can indicate what type a variable is, like what kind of data is it. So first name, for example, is a string. So TypeScript will infer that first name is a string just by having it like this because the value is Jonathan. But we can't do is we can no longer do first name equals like 10, for example. TypeScript will yell at us. So this is the big difference in why we're using TypeScript. If you hover over it, it says type number is not assignable to type string. These two types don't match. First name is a string, 10 is a number. Those are not the same. So you can't just dynamically type first name as you go along. First name has been declared as a string on line 3 and therefore cannot be changed on line 5. So TypeScript is literally showing us this like error, and this looks, if you've done C# or Java before, you know what this feels like. You've had this experience. All right, so because first name is a string, it cannot be assigned to a number, it cannot be assigned to a Boolean, it's a string. That's the way it works. Now you can be more explicit. Now TypeScript infers that the variable first name is a string because you said to a string. But you can be more explicit by doing colon and then typing string afterwards. Right? That says that first name is of the type string. And we can do this with anything else. So other JavaScript primitive types. So like let number of people colon number equals 100. Let is premium member Boolean equals true. And now you can see that this is where the type in TypeScript comes from. We are adding types to variables. We're saying that this variable is a number, this variable is a Boolean, this variable is a string. And now because we are statically typed, I cannot do is premium member equals, I don't know, something like some sort of like string, because those types are a mismatch. And that's what TypeScript is doing for us. It is basically checking to make sure that everything is type safe, and then when we're ready, it will transpile into a .js file. So let's go ahead and do that actually. I'm going to make sure it's saved. I'm going to do tsc index.ts and see what gets spit out. All right, so let's look at our index.js file. It got updated, and now it will do this for us. All right, so this is what the vanilla JavaScript that we all know and love would work. So notice that, however, all that string and number and Boolean stuff got taken out, and we just declare variables as you normally would in JavaScript. So that's kind of what I mean by TypeScript is like a copilot, because again, TypeScript is not the thing that's actually like running on the computer that the user will eventually like interact with. It is sitting there watching us, making certain that, for example, if we say something's a string, that later on we don't just willy-nilly decide it's a Boolean later. All right, so it makes sure that everything is type safe. So it's TypeScript, I kind of think of like a nun standing up like behind you over a desk with a ruler in her hand. And if you like, go outside the line, she'll let you know. All right, so that is essentially what TypeScript does. These are TypeScript variables. You can indicate that a variable is of a certain type by putting the colon and then the kind of variable afterwards, a type like string, number, or Boolean. This is not necessary though. You could leave that out, in which case it will infer or basically figure out that, hey, there's a string here, so therefore first name must therefore be a string. All right, so that's basic variables. Let's move on with some more types. So we can represent all of the basic primitive data types in JavaScript. I have examples here for string, number, Boolean, big int, and symbol. One little small caveat for big int, you're going to have to go into your compiler, tsconfig.json, and go set the target to ES2020 in order for there to be support for big int. So if you have to actually use one. and then we have symbol, and these are the primitives. But let's just say for the sake of argument, you had a variable and you didn't know what it was going to be. Because a lot of times in JavaScript, we have a variable coming in and we may have absolutely no idea which of these things it could possibly be. Or maybe we're okay with it being any of them. Right? In which case, that kind of gives you a clue as to what the keyword is going to be. Let's have let this could be whatever, colon any, equals, and then from here you can do what you want. So I can put my name in here, okay. You also could let me put the semicolon, and then this could be whatever equals false, and then this could be whatever equals 100, right? So it works more like regular JavaScript in that it will be dynamically typed based on what the current value is. So if it's set to a string, then at that moment it's a string. If it's set to a Boolean, then at that moment it is a Boolean. All right, but by doing any, you can put anything in there. Now, some people are divided a little bit. They have strong opinions about any because it kind of undoes the entire point of TypeScript to be able to do this. But there are plenty of cases where you're not necessarily sure what the type is going to be beforehand, in which case this can be very convenient to just basically say, cool, I will accept whatever type you give me, right? So that is the any key, the any type. Okay, any accepts any type. Okay, so anything can go in here, and then it operates a lot more like just plain old vanilla JavaScript. One of the cool things we can do in TypeScript is that we can have variables that could possibly be multiple things. So for example, I could put let example variable string equals example, and we already know how to do this. It's a string, but what we can do also is put this bar here, and then we can put another type. All right, so we could say that this variable, example variable, could be either a string or a number. So I could set this to 10, or I could set this to some string. And the TypeScript compiler will be happy with me because I said here that example variable will be either a string or a number. Of course, that does not mean it could be a Boolean, so I cannot therefore set it to true, because true is a Boolean, it's not one of the types. But if you have a variable that could be more than one thing, then you can use the union, which is this bar, and you can say it's either one of these things. Now, you can add multiple things. Okay, if you want to have more than one, you can have 3, you could have 4. That's what you would like to do. The order doesn't specifically matter. I can put number, string, Boolean, or however I want, but this union allows there to be more than one type. What commonly is used for this is for things that are nullable. So some like nullable thing, which could be either string or null. Okay, so in this case, you have something that could be nullable thing is equal to null. Like for example, maybe you're making an API call and it didn't find it and you're getting it back, or you do get it back. So if you have some sort of situation where something could be null or something could be something else, actually have a value of something, then you can use the union to basically do null. The same thing would work also with undefined. So you can have undefined, okay, as another type that it could be. All right, so this union, which is this symbol right here, allows a variable to be one of multiple types. Now remember, this is a little bit different than any, right? Because, for example, example variable could be string, number, or Boolean. It can't, for example, be like something different, like example variable equals big int something, right? Like that would not work because big int is not one of the 3 types listed in this union. If example variable were any, then it would work because any is literally anything. All right, so that is one of the little things that some people make a mistake with union. It basically says it has to be one of these types, right? And this is very, very useful. Now that we've done variables, we can move on to functions, and they're very, very similar to how you would normally write them in JavaScript. So let's say that we have a function, add 2 numbers, which will take in 2 numbers and give back their sum. All right, so again, I just wrote this normally so far without any additional typing, but let's go ahead and put our parameters in. So we'll do, the first one should be first number, which is a number. Notice how I put a colon, and then the type, like I did before, like a regular variable. And then we'll do second number, colon, number. All right, so as you can see, we added types to our arguments. And then after the parentheses, before the curly brace, we're going to put a colon, and then the return type. So this part says this function is expected to return a number. And notice how we've got the red squigglies. That means that because there is no return statement here just yet, it will not compile. All right, so if you go over it, it's function's declared type is neither undefined, void, nor any, must return a value. So let's go ahead and appease TypeScript. We're going to return first number plus second number. All right, and then TypeScript is happy, right? Because we said that this function is expected to return a number, and we've done just that. We're returning the sum of the first and second number. Now notice, because this is number, that means that the return type must match. So for example, I can't make this a string. Okay, that's because string, this right here is a string, and it's expecting a number to be returned, so that won't work. So the two types have to match. Now, if you don't want to return anything, you can use void. Okay, function that returns void returns nothing. So if it's void, you should not have a return statement. Okay, because it doesn't return anything. So right here we have a function add two numbers, but it returns void. So notice there's no return statement. Okay, but we do want a return statement in this case because we're adding two numbers together, so that would make sense. Because there's no return statement, it's not compiling, so we will fix that by doing this. Okay, and then all is well. Right, so you'll notice that, again, functions look the same as they do in JavaScript, except we're just adding a little bit of extra like type information to our code. Now, a couple things. This part is optional, this return type. You can go, if I were to leave it off, TypeScript will be able to infer that this function returns a number. Why? Because this is a number. It's the same exact idea as when we did this. We originally could write this statement, let first name string equal Jonathan, and then I can get rid of this, and it still knows that first name is a string because it was set equal to a string. And it's exactly the same logic for functions. It could infer that this returns a number. It's usually good form to have the return type spelled out. I would personally recommend that. It's easier for other devs to know when they start fiddling with your functions what to do with them. Now, let's call this function like we normally would, and as you can notice, I can put numbers in for the arguments. If I were to put a string or a boolean or anything that isn't a number, then it will not compile because the the method signature basically says they're both numbers. All right, so TypeScript will check to make certain that we are passing the correct data into the function. Now the cool thing is that you can use unions here, like we just learned, and you can put like number string, for example. Now that will cause some problems inside of the function, because if something is both a number and a string, if an operation can only be performed for a string or only can be performed for a number, then you're going to have to use if statements, right? So in this case, let's say like we allow them to put a string or a number, right? That would make a lot of work on us. Let's say we did that. So if type of first number is equal to string, let's say. Okay, oh, gotta put quotes around it. Okay, in which case we can return and try to like, again, this is pretty contrived, but just to kind of show you how we can use if statements. Else returns first number plus second number, right? And as you notice that this compiler is fine because we've used if statements to sort of handle the different possibilities. So using union, I basically said first number could be either a number or a string. Okay, this is a contrived example, but it does get the point across. And notice how originally, when we had our original code, first number plus second number, we got a compilation error because it couldn't necessarily apply this plus operator to a number or a string. It doesn't really know what first number is as it stands because it could be one of two things. So the way to fix that is to use if statements. You can use type of to say like, hey, like what is this variable? Is it a number? Is it a string? And I'm using if statements to handle both cases. I don't have to have an if statement for like if it's a boolean or something like that because it can't be, because it's only one of these two things. But I say, hey, if it's a string, I'm going to cast it as a number and then add them together. Otherwise, I'll just add them together. All right, in this case, the compiler is happy because we've taken care of all possibilities given by this union. Okay, so just keep that in mind. If a parameter is like this, you can handle it with if statements. So now when I do my function call, I could either do add numbers 2 as a string 3 or just a regular number. All right, and then because of this union, that makes it possible for me to do. Another thing we can do, okay, I'm going to go back to the way things were. I'm just going to have number here, and then just return first number plus second number, is that I can make my parameters optional. So for example, I can add a question mark here like this. Now notice I got a compilation error because first number is possibly undefined. So what this question mark here means is that this first number variable, it's possible to give, it's possible not to. So on line 5, I could have 2 and 3, or I could just have 3. Okay, so it's possible for me to do that. Okay, the order will matter, so actually the optional parameter has to come in last. So you can't have a required parameter after an optional parameter. So when I did this, first number was an optional parameter, but this is a required one because it doesn't have a question mark, but they can't be in this order. The optional one has to come after the required one. All right, so I'm going to put one here. All right, and it's going to tell me that second number could possibly be undefined, so we'll have to use an if statement to handle that. And again, a little bit of a contrived example, but it gets the idea across. So if second number is undefined, we'll return the first number. Okay, and that way we've got everything, all the possibilities handled. And so now on line 8, I can either put 2 and 3, with 2 being the first number, 3 being the second number, or I could just put like 2, all right, and the compiler will be happy because this is optional, meaning that the user does not, the client, the person using the function, does not have to necessarily provide this. So as you can see, TypeScript gives us a lot of flexibility into whether or not we give certain data to the function. The types, we can use unions, okay, but the inside gets a little bit messy because we're going to have to check to see, for example, if it's undefined or if it has a certain type and handle all the different types if it's a union. So TypeScript can add a little bit of extra work, but some people believe that that's actually a good thing because we are coding defensively. We are coding to make certain that we handle all possible outcomes. All right, so now we know how to write functions. Okay, we know how to use optional parameters by using the question mark after the variable name. We also understand that we have to have if statements to handle optional parameters in case they're undefined, in case we have some logic using them. And then we also know how to use union, how to use the union symbol to say that a parameter could be different types, all right, and to be able to use if statements and type of to be able to handle it. So we can do quite a few things with functions in TypeScript. All right, interfaces. So interfaces basically tell us the shape of data as we expected. And that's the typical thing you'll hear. Let's see what that actually means. So let's say I have interface player. Let's say we're making a game of some sort. And then I'm saying, okay, a player is a thing with what? All right, so we're kind of describing what a player is, like what properties it has. So it's not like a class though. But let's say a player has a name, and they have like a level, and level number, and then we will say they have maybe like XP, which is also a number. All right, so basically what this interface is saying is that if you have an object, then the object that uses this interface player is going to have a name, a level, and XP. So for example, I could do let new player colon player, and I could use like a type here. All right, so that means that new player follows this interface. All right, and you'll notice that initially I have a compilation error. It's saying the type is missing the following properties. So I'm going to have to actually fill these in. So I'm going to do name, which is, I don't know, Indiana Jones. And then let's say his level is, I don't know, 50. His XP is 100,000. All right, and notice that we now compile, all right, because this new player object, okay, is using the interface player, so therefore it must have a name, which is a string, a level, which is a number, and XP, which is also a number. All right, notice that I have all these three things, and if I don't have one of them, I'll get a compilation error. Okay, so it's enforcing the shape of my data essentially. So if I put in something bizarre, like, I don't know, is rewards member or something true, then it will be like, hey, what's this? That wasn't in the interface. I don't know what you're talking about. All right, so the interface is pretty strict. Okay, it says what data should be in the object, okay, the name and the type, and then you must have these, okay, they must be there, and you cannot have more than that. Now, if you would like to make one of these optional, you can use the question mark here, so I can go here and be like, cool, right, then it'll be undefined if you do not put anything there. So if you want to have optional properties in your interface, you can, but as you can see, you can also make them required. So this is actually quite useful in making sure the data comes in as you expect. Now, interfaces come in handy with functions especially. So for example, let's say we had like function level up. So like we were leveling up a player in a game. All right, and so we have player colon player. All right, so now we expect that the data coming in is going to be using the interface player, so that we know that it's going to have a name, a level, and XP. So maybe we could do like player dot level plus equals 1, okay, to like level them up by 1. All right, so that would be a usage of the interface like in a function. Okay, so should say it's void, just to be explicit about it. But now we take in an object, which is a player. Okay, again, this is not a class per se, so the interface is not a class. It's basically what it's saying is that the object that implements this interface, okay, has this shape of data. This is the data that you should expect from it, and this is the type of data you should expect from it. So in some cases, some people confuse this with a class. It's not really that. It just basically tells you like what should be there. It's kind of an enforcement mechanism, so that like when you have functions that rely on objects that use this interface, you are assured, okay, that these pieces of data exist and you know what type that they are. Okay, so interfaces are very, very useful, and you're going to use them all the time. But it's important to kind of understand this difference between like what you in another programming language you may have used the interface for, and what this is more talking about. This is more talking about what data can you expect to exist in an object that uses this contract. Interfaces often come up also in collections. So we have arrays, all right, and arrays are very a common data structure that you're obviously going to use a lot. So let's learn how to actually implement them. Let's do let player array, and then it is of the type array, and then array will take a generic. So we have these angle brackets here, and then I'm going to say it takes an array. Let's do a simple one first of string, right? So here you go. We have a player array, and then if you want to start off with nothing in it, you can just basically use the square brackets. And since it's an array of string, that means everything inside of it must therefore be a string. So we have like John, Bob, Billy Bob, okay, whoever you want, right? Each individual element within this array is a string, right? So we can't have any numbers, any booleans, anything that's not a string. This is an array of string. We have that T, this generic here, to basically strongly type our array. We can also do the same thing with interfaces. So I can have an array of objects that implement a certain interface. So I can have an array of player, all right? So in here, the way it would look is I can have an object, and then I would have to fill in all of the data myself. Okay, so level 50, XP 100, all right? And therefore we have an object, all right, that follows this pattern. Okay, and then you can have multiple ones. Okay, so if you want to have like multiple objects in your array, that's fine. Okay, Joe, and then he's level 50. He's like level 5. He's a noob, and he only has 1 XP. All right, so now we have a array of players, and each of them is an object. Okay, that has name, level, and XP, and that's because they all have the interface player. All right, so this is another common place for interfaces to pop up. You can also do maps that are strongly typed. So we can do map. Let's do dictionary, which is a map, and then we're going to use generics. They have a key and a value. So let's say the key is, I don't know, a string, and the value is an integer. Okay, which will be number, excuse me. So we're going to do let dictionary map string number, all right, is equal to, and then you actually just do new map here to start off. And then now notice I can do dictionary.set. Okay, and inside expects 2 arguments, the first being the key and the second being the value. Notice how the key is a string and the value is a number, right? String number. Okay, so it will Typescript will make sure that we are following the correct type. So I can put alligator, and I'm just putting random things in here, but alligator 10, for example. All right, and again, because the key is a string, it must be a string. The value is a number. It cannot be a boolean or anything else. It will not match. So TypeScript is always looking over our shoulder to make certain that when we say something is of a certain type, that we are being consistent. All right, so now we know how to use arrays. You can have a strongly typed array. You'll have array with angle brackets with a generic. And inside you'll have the type of array. And again, you can actually use unions here as well. So you can have like string, array of string, or number. Okay, if that's what you felt like doing. but you also will most likely use an interface. That's pretty common. And then you can have objects that implement this interface. They follow the same pattern. You also have maps. Maps can be strongly typed too. So you have like a map of, let's say, string and number. All right, and then when you use set, you'll have to follow the same type. All right, so you will be also able to use interfaces here if you so wish. So interfaces pop up in a lot of places where we would normally use objects. All right, so now we know how to use collections in TypeScript, along with how interfaces work with collections. Classes will look a lot like they did in JavaScript. However, there's going to be a couple little minor details. And again, as always, we're adding types to everything. So let's say we have our online MMO. So we got class player. All right, so far so good, nothing different. All right, so let's say we had some properties of the class. Let's say the player has a name, which is a string, and also let's have have a level, which is a number, and they have maybe like a homeland, which is a string. Now notice that the compiler is giving me a bunch of compile time errors saying it has no initializer. All right, so what that's basically saying is that as it stands right now, name is a string, but it has absolutely no value. So we have a couple things we can do. We can give them a default value like this by just basically putting equals and then putting something here. All right, basically saying, hey, the default, like the beginning initial value is blank string. If that's what you want to do, you can do that. Or we can do it through the constructor. All right, so we'll do constructor, and then we'll do name, which is a string, level, which is a number, and homeland, which is a string. And then we would do this dot name equals name, this dot level equals level, and this dot homeland equals homeland. And notice how all those compile time errors just went away, because now we are initializing these values with what's coming in through the constructor. Okay, and this constructor is here to just basically say, hey, I need this data to make a player, and the first thing is a string, the second thing is a number, and the third thing is a string. All right, so this is the basis of a class. So when you have these properties, you're going to have an initializer. Either you could set that here yourself, okay, in the beginning, basically say it's some value, or you can put it into the constructor. But if it's not put in either place, you'll get a compile time error. Now, a couple things we can do with this is we also can you can kind of condense this a bit if you'd like to. So for example, all of these properties right now are public. So public name string, public level, and public homeland. We didn't have to write the word public, but they are public. All right, so, but you don't really have to write this because it will just be public from the get-go, so, which is fine. You can even tighten this up a bit, so I don't have to necessarily write all of these properties here. What I can do is inside the constructor, I can actually put public here, public name string, public level number, public homeland string, like this, and then it's all good. So you could actually condense a lot of the typing into just a constructor like this if that's what you would like to do. So access modifiers, we could talk a little about those. So here I have, these are all public, and what that basically means is that if we were to put this elsewhere, we would be able to use them. So I put this export class player, that way we're going to use this as another file. So we have export class player. I'm going to make a new file, just call it like other.ts, and I'm going to import it. So I'm going to import player from the other file, and now we can do like a new player. So now I can instantiate my player class. So I can basically do let player, which is of type player, equal new player, and then we'll call him Indiana Jones, who's level 100, and he's from, I forget, I don't remember the movie. Let's say he's from Indiana. Okay, all right, so now we've got that. So now if I do player dot, and notice I have access to homeland, level, and name, and so because they're all public, you can change the access modifier. Let's say, for example, I had a name, right? So let's say I had not a name, excuse me, the age. So I could do private age, which is a number. Okay, so it's going to yell at me about this having no initializer, so I'm going to add that to the constructor. And then do this dot age equals age, right? So this is private, so I'm going to adjust this. Let's say he's 50. I don't know how old Harrison Ford is, but he's got to be at least 70. All right, so now when I do this player, notice how age does not appear here because age is private. So what private means is that this age is only allowed to be used inside the scope of the class. If we were to go outside of the class, like anywhere else, then that age property does not exist. So you may want to have the limit access to certain fields of the class outside of the class. You can do that with private. Otherwise, they're just public. All right, so that would make sense. Now, you also can use the JavaScript, the ECMA private hashtag. So let's say there was something else about the class I wanted to make private. So for example, maybe it's like is playable. So you can do like this, is playable, Boolean. And this hashtag basically means it's private. So we can do, and we'll just basically set it in the constructor, is playable, Boolean. And then we follow this hashtag is playable equals is playable. All right, and then we'll need that in the constructor. Right, and again, the same thing is that we will not be able to get that because it is private. All right, so you can use both. There is a difference between these two in terms of runtime versus compile time, whether they'll be enforced. We won't get too much into that. I just wanted to make certain that you understood that you can use private, or you also can use the ECMA hashtag here to represent a private field. Now, as far as classes methods are concerned, they work just like the way they used to, except you're going to add types. So, for example, maybe you want to have level up, like maybe a level up function. So we have level up. Okay, which doesn't take anything in and returns void, for example. And we can say when they level up, it's this dot level plus equals 1. All right, so we have a method, and again, it follows the same rules as functions. So you have a return, you have parameters, maybe you have optional parameters, maybe you have unions. Okay, it's all depends on you, but you have a method, and again, it's public off the bat. So I can do player dot level up like this, and it's fine. If I set this to private, so if I say private level up, then this will suddenly give me a compilation error because it is not accessible outside of the class. All right, but you don't have to do that. If you want to just leave it public, that's fine. You don't have to even write it. Right, but sometimes with private methods, you want to have a method that's only available inside the class. You don't want outsiders to be able to deal with it. So you can use these access modifiers to sort of declare how the access you want to give people to certain methods or certain properties, which is fine, right? So you have that option. All right, so there's even more you can do with classes. So like in all good object-oriented programming, we are able to do inheritance with classes. So I've got an eagle class here, where eagles have a feather color and speed, and I have pretty much the same thing for a hawk. The only difference is that their fly methods are different. So this would be a great example of, hey, I'd like to sort of consolidate all their code in the parent class. All right, cool. So I made a class, let's make a class called bird. So we're gonna do export class bird. All right, and then I'm going to go ahead and put the constructor and the feather color and all this good stuff into the parent class. And then now to inherit from the parent class, all you have to do is extends bird, right? And we need to import bird from bird, and now we are able to inherit all of the properties and methods from the parent class come into the child class. And so that way I can kind of consolidate. I don't have to have all of this excess code, right? Repeating myself, extends bird, and I did tab to import it using VS Code, so it makes it quite easy. So now we have a class eagle which inherits from bird. And that basically means that all of the feather color, the speed will come down to the hawk and the eagle. All right, so let's go ahead and just kind of show this off. I'm going to make a file called index.ts, and I'll make a new hawk. So we'll do let hawk, which is of type hawk, equals new hawk. Right, and it's going to not know what I'm talking about, so I'm going to go ahead and do quick fix and add the import, and then it expects a feather color and a speed, so we'll say brown and we'll say 100, right? And then we can say let eagle of type eagle equals new eagle, and eagles I guess are white with black feathers. I have absolutely no idea, and there we go. And we can go ahead and import that as well. Quick fix, there we go. And now we've got hawks and we've got eagles. All right, and now they are able to inherit from bird okay, by using the extends keyword. So we did class hawk extends bird. Now, TypeScript also has abstract classes. If you know abstract classes from other object-oriented programming languages, then you know the abstract classes are great for when we want to prevent our developers from instantiating a class they shouldn't be able to instantiate. So, if, for example, it makes sense for our bird watching app to have hawks and eagles. It does not make sense for our bird watching app to have the concept of bird, because bird is too abstract of a concept. You can have a hawk, which is concrete, or an eagle, which is concrete, but hey, I don't want to let someone do this, right? Let new bird equals new bird, right? So as long as it's able to do this, I may run into some problems in my app because bird is too much of a abstract concept. Okay, but as it stands right now, nothing is stopping me from doing line 9. So here I can do export. So before class I can put abstract. Okay, so this makes the class abstract, and what that basically means is now it is not instantiatable, right? So I cannot create a new bird like on line 9. The compiler will yell at me, and so this is no longer possible. So I will only be able to instantiate subclasses of bird. All right, so we have abstract class bird, which helps us in enforcing that. So now my app, it makes sense. Like, you know, bird, the concept of bird is too abstract for me to instantiate. There are also abstract methods. Let's say, for example, all birds can fly. Currently, I have it both in hawk and eagle. I have a fly method here and a fly method here. But I'd like to enforce this, right? Right now, I could create a new subclass. So let's say we have birds, we have eagles, and we have pelicans. Okay, pelican.ts. And so I can create a pelican. So export class pelican extends bird, right? And we'll have to import this. Okay, and it's a pelican, but right now there's no fly method, right? And birds are supposed to be able to fly. So what we could do is here we could add an abstract method. So I'm going to do abstract. Let's say fly void. Okay, which will basically say like, hey, like if you are subclassing bird, you need to have a method like called fly, which returns void. Oops, forgot the parentheses here. Right, there we go. So there you have to have an abstract fly void, which basically says, hey, if you subclass bird, then you need to have a method called fly, which return type is void. So here we go with fly. This is void. We're good. Notice how pelican now gives us a compiler like error. So now we're going to have to go ahead and do fly void. Not sure how pelicans fly, but we'll do console.log. The pelican flies majestically, okay, because I'm sure that they do. All right, so now because, again, this is an abstract method, what an abstract method basically means is if you subclass this abstract class, then you must have a method with this signature, and you must put some implementation into it, right? That way, anything that subclasses bird, we are assured that they can fly, so our bird watching app will work the way that we think it does. All right, so now you're able to use abstract classes. Okay, so you can decide if you want to make it a concrete class or an abstract class, and we can use the extends keyword to inherit. Keep in mind a class can extend at most one other class. All right, so we don't want to allow multiple inheritance. Okay, so I can't extend bird and something else. I can extend at most just bird. Right, and this is why we can use inheritance with classes like we would with a lot of other object-oriented languages. All right, so most of this stuff the concept should be fairly good, but if not, then check out my JavaScript video and it should help with some of these ideas. If you've gotten this far in the video, thank you very much. I hope that you learned something about TypeScript. This tutorial is by no means an exhaustive list of every little thing in TypeScript. There's plenty more details to go over. And if you'd like to take your TypeScript to the next level, I highly recommend typescriptlang.org, which is the documentation for the language. They have an excellent section that if you come from another programming language like Java or C#, they have little get started guides that help you to compare the languages. It helped me a lot when initially, years ago, when I started learning TypeScript, to sort of wrap my head around the different ways in which they handle the same problem. Again, if you like the content of this video, please like and subscribe. I love making these videos for folks that want to get into tech. I like to make it as easy as possible. And if you'd like, please consider joining our Patreon.